Good morning, class. Hope you're doing well. So today we'll just continue to talk about quadratic functions, and in this unit of polynomial and in this unit of polynomial functions. So the output or the value of a quadratic function at the vertex is the maximum or minimum value of that quadratic function. That's our first idea. And I hope you can see from these diagrams or from these graphs or parabolas that this is the vertex, that is also the vertex, and the values of y at those points are going to be either the highest or lowest values of those functions. So in this function it has a maximum because this is the highest value, this one has a minimum because that is the lowest value. The vertex is -1, 2, therefore its maximum value is 2. The vertex of this one is 3, 1, therefore its minimum value is 1. Yeah, this is what we just talked about. We have an example here. So we're looking at applications of quadratic functions, and this farmer wants to encircle or enclose a rectangular space for a new garden with fenced backyard. She has 80 feet of wire to enclose 3 sides. She will use a section of the backyard fence as the 4th side. So find a formula for the area enclosed by the fence if the sides of the fencing perpendicular to the existing fence have length L. So we know that first of all perimeter is equal to 2L plus 2W, and from that formula perimeter is twice into L plus W, and this lady has 80 feet of wire fencing, so that's going to give us 40 is equal to L plus W. Now I know initially that the area is supposed to be equal to length times width, but since I have an expression for length plus width here, I can substitute for either of those functions. Because from this expression I see that if I take width to the other side, then I have L is equal to 40 minus W. So my area is L, which is 40 minus W, into width. Or if someone else had used a different substitution, they would get an area of 40 minus L proper L, times L. So that is going to be your expression for the area, and I hope you can see that if I expand it out, 40L minus L squared becomes a quadratic expression. So yeah, the width is 80 minus 2L, and the area is 2L squared plus 80L. Wait. Oh yeah, my mistake here was to forget that this person is only fencing 3 sides. She's only fencing 3 sides. So only this side and this side is a different color. This side, and then this side. So it's 2L plus width, not 2L plus 2 width. Apologies. So doing that again. This is the formula for perimeter, but for this case it's 2L plus width because there's only one width. The other side is covered by the wall. So again, in that case, 80 is her perimeter is equal to 2L plus width. Therefore that means that 80 minus 2L is equal to her width. So if I substitute in a formula for area, length times width, the area won't change. I will have length, which is L, and width, which is 80 minus 2L. And if I expand that, it's 80L minus 2L squared. Or I can rearrange it so that the quadratic term comes first. So this is my function for the area. It's my function for the area A, or I can write it as a function of the length. Okay, so we're back at level. What dimensions should she make her garden to maximize the enclosed area? Now our function for the area is negative 2L squared plus 80L. I know that since this is a negative sign, the graph of that function looks like this. And the graph of that function being like that means this point right here is the maximum value of the function, and I know that that point is the vertex or the axis of symmetry. So all I need to do is find that value of x, then use that value of x to find the value of y, which will be the maximum value. So step 1 is I'm going to find the x value of the vertex, which is x is minus b out of 2a. Minus b is 80, so minus 80 divided by 2 times negative 2. So I hope you can see that 80 divided by 4 is 20. That's my x value. And if that's my x value, then I can just substitute that value into the expression for area to get the maximum value of the area. So that's going to be a is equal to negative 2 into 20 squared plus 80 times 20. So we have 20 squared is 400 times 2 is 800, negative 800, and 80 times 20 is 1600. So 1600 minus 800 is still 800. So the area is going to be we were solving for what dimensions you should make a garden. The answer to that is 20. That's the dimensions. The length should be 20, and if the length is 20, remember from this formula on the previous screen that width is equal to 80 minus 2L. 80 minus 2L, so the width will be 80 minus 2 times 20, which is 80 minus 40, which is 40. So that's the solution. I had gone ahead here. I'd gone one question ahead. For this question, we're just solving for the dimensions. Those dimensions are length is 20, width is 40. Simply. And if we want to find the maximum area, or what the maximum area is, that's the work I just done earlier, where I substituted for the value of L into this expression, which this I did on the last screen, and then I ended up getting 800 square, is it centimeters or feet? Yeah, square feet, or feet squared. Another example, a ball is thrown upwards from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by this equation. When does the ball reach maximum height? So, same thing. This equation is a quadratic equation that will have a shape like this, and this is the point where it will have its maximum value. Remember, this one is thrown from 40-foot high building. Yes. Let's try to analyze this. I'm again trying to find the value of x at this point, which is x is minus b out of 2a. So from comparing this, ax squared plus bx plus c, I hope you can see that b is 80, so this x value is going to be negative 80 divided by 2 times 16 is negative 80 divided by, this was negative 16, which is negative 32. 80 divided by 32 is, and so the x value is 2.5. In order to find the maximum height, I just substitute that x value into this expression to find the maximum height. This is 2.5 seconds, by the way. So substitute for negative 16, 2.5 squared plus 80 times 2.5 plus 40. That gives me the maximum height. You guys can substitute for that. What is the maximum height of the ball that's what I just showed you. Substitute for this time in this expression. Everywhere you have t, substitute for 2.5 and work out the maximum height. When does the ball hit the ground? When does the ball hit the ground? So at the ground, what is the height of the object above the ground? At the ground, the height is 0. I hope you kind of get that, because when it goes all the way from up here, from here to here, it was 40 meters. Then you calculated an extra maximum height that you got. I don't know what you got here, but that's what you calculated. So let me just check this. This question doesn't specify maximum height above the ground or above the building, but if it was above the ground, this one exactly, but if it was above the ground, then you will add the 40 meters to your answer from substituting 2.5 here. That's just to clarify. So yeah, if he had specified above the ground, you would add the 40 meters. Since it doesn't specify, you're okay if you do either solution. When does the ball hit the ground? Yeah, so at the ground, the height above the ground at this point is definitely 0. So I'm just going to substitute for 0 is equal to negative 16t squared plus 80t plus 40, and try to solve for this quadratic equation. Trying to solve this, I can see that everything is divisible by 4. So if I divide by 4 throughout, I have 40 squared plus 20t plus 40. Wait, not just 4. There's more. There's another 4. No, sorry. 40 divided by 4 is 10. So really everything is divisible by 8. 8. Divided by 8, divided by 8, divided by 8. Simplify this, 2t squared plus 10t plus 5. This is a quadratic equation which you guys are pros at solving. I can rearrange it so it looks better. And then I just try to find two numbers that I multiply to get 10, multiply to get negative 10, and add to get negative 10. Yeah, I'm going to use completing the squares because that's my favorite method. You guys can't say no because you're not here. So completing the squares, first of all, t squared minus 5t. You guys can use quadratic formula. I'm not forcing this on you. Minus 5t minus is equal to 5 over 2. What I've done is I've divided here by 2, by 2, by 2, and then I've taken this term to that side. So nothing major. Next, I'm going to take 1t from here, then I'm going to take half of 5. So t plus 5 over 2, no, minus 5 over 2 squared is, then remember I have to subtract the square of this. So minus 25 over 4 is equal to 5 over 2. So my t minus 5 over 2 squared is equal to 5 over 2, which is the same as 10 over 4 plus 25 over 4. T minus 5 over 2 squared is equal to 35 over 4. T minus 5 over 2 is equal to the square root of 35 over 4. So I end up with t is equal to 5 over 2 plus or minus square root of 35 divided by 4. So the challenge is for you to use quadratic formula, or you can just sketch this graph on Desmos or something really and find the points of intersection, because at this stage you would be wasting a lot of time to solve it because you're only interested in the solutions at that point. So you want to try to solve it in as little steps as possible. So this is something else you can do. Go to Desmos, type your equation, 2x squared minus 10x minus, was it 5? 2x squared minus 2x squared minus 10x minus 5, yeah. And you just look for the points where it cuts the x-axis. This is the first point, which is a negative. We're going to ignore that point because we don't have negative time. And we're going to use this point, which is 5.458. That's the point we're going to use. That's the time we're going to use. So we get two values, but we discard one of them. So t is 5.458. Alright, Soccer Stadium has 80,000 spectators. Awesome. With a ticket price of 15, the average attendance has been 45,000. Now immediately what I see is they're giving me values. I'm getting a value of price and I'm getting a value of attendance. Right? And then that changes. When the price dropped to 12, the attendance rose to 51. Already I have 2 points, and when I have 2 points, first thing that comes to mind is slope or line or equation. And sure enough, the question goes on to say the attendance is linearly related to the ticket price. What ticket price would maximize the revenue? So before I even look at maximizing the revenue, I want to first figure out what is the price equation. So just like I wrote earlier, I have two data points, 15, 45,000, and then I have 12 and 51,000. So I'm going to find the slope of this line. After finding the slope, I'll find the equation of the function of the line that goes through these 2 points. I hope you remember how to do that. So your equation will be y, because point slope form, y minus y1, which is like y minus 45,000, is equal to m. But remember, m is the change in y over change in x, which is the change in y is y2 minus y1 over x2 minus x1. So I'm just going to substitute for those values. y2, I can use 51,000. y1 is 45,000 over x2 is 12 minus x1 is 15. That's going to be my slope. But when I'm doing point slope form, that slope is multiplied by x minus x1, and x1 is, since I used 45 this point, x1 is going to be 15. So you simplify that and then you work out the equation of the function. Just make sure that your equation is this, because that's what you get when you simplify that. Right, the revenue equation, we know that revenue, amount of money you make, is equal to number of items you sell times cost per item. So the revenue is simply going to be price times price per seat times number of seats. So if I know that that's the revenue, already I have an expression for the price. So my revenue equation is just going to be the equation for price times x, because that's the revenue function. Okay, so if I multiply that out, that's what it gives me, 2000x squared plus 75,000x. What ticket price would maximize revenue? This equation, again, because of this negative, would look like this. So you're looking for this value of x, which you're going to find using x is equal to minus b out of 2a, which will be negative 75,000 divided by 2 times negative 2,000. When you get that x value, substitute it into this revenue equation to find the maximum value of the function. Alright, last one. Among all of the pairs of numbers whose sum is 6, find the pair with the largest product. Find the pair with the largest product. Is that it? Oh, also wants us to tell what the largest product is. Okay. Right, so there's so many pairs of numbers whose sum is 6. There's 1 and 5, there's 4 and 2, there's 3 and 3, there's -2 and 8. Lots of pairs that you can find whose sum is 6. But which pair has the largest product, and what is that product? So first of all, I know that the sum is 6. So x plus y is equal to 6. So I can make y the subject, and it will be 6 minus x. And I know that the product, the expression for the product, will be x times y, right? So the function of the product is x times y, which is x times 6 minus x. That's the function of the product. So my function of the product is, and remember in this case x simply means product, but here x means the y value. So if I expand this, I have 6x minus x squared, which can be written as x squared plus 6x. Again, a function that looks like this. I need to find the value of the x of the axis of symmetry, and that value of the axis of symmetry, once substituted into this function of the product, and we call this fp, so I don't confuse you, is going to give me the maximum product. So x is -b out of 2a, b is 6, so -6 out of 2 times -1, which gives me 3, and when I substitute that 3 into this function, it should give me the maximum value. So the maximum value is going to be -3 squared plus 6 times 3, which is -9 plus 18, which is 9. So that is the maximum product of x and y. If I want to know which values are these that give me the maximum product, remember I found the x value to be 3. If the x value is 3, I just need to substitute it into this one to find the y value. If I substitute it in this one now, take note, if you substitute that x value into the expression for the product, into the function of the product, it gives you the maximum value of the product. It doesn't give you the other number, which makes that product maximum. But if I substitute it into this initial equation of the sum, then that gives me the other coordinate, that the other value of y that makes the product maximum. So here y will be 3. So the pair of numbers that you can add to get 6 and who have the highest product is 3 and 3, which is 9. Okay, this is your homework. Have fun, enjoy, bye.